Okay, let's unpack this. Living here in Florida with my own herd of goats, I've uh, I've seen firsthand how our amazing animals just seem to thrive. You know, even when the humidity is so thick you could chew it and the temperatures are just soaring.
Oh, yeah.
They really are incredible, resilient creatures, aren't they? They just seem to make it work somehow.
They really do. It's quite remarkable.
Today, we're diving deep into something that's absolutely vital for goat owners everywhere. But especially for those of us navigating the challenges of hot, humid climates, the specialized nutritional needs of goats. You see, goats aren't just livestock. They are absolutely crucial for livelihoods around the world, providing high-quality protein and dairy, and they're incredibly widespread, especially in rural households,
Yeah.
largely because of their remarkable resilience.
That's right.
Many of them are raised in really hot places, from the desert to the Middle East to the humid tropics of Brazil, right down to my own backyard here in Florida.
Exactly. They cover a huge range of environments.
But here's the thing, and it's a critical challenge.
Hmm.
While they're undeniably tough, that intense heat stress does negatively affect their performance, whether we're talking about milk production, meat gain, or even their ability to reproduce effectively.
Right. It takes a toll.
It's like us trying to run a marathon in a sauna. We can do it, maybe, but we won't be at our peak. So our mission for this deep dive is to go beyond the general feeding guidelines you might find in an old textbook and truly understand the specialized nutritional needs of goats in these hot environments.
Yeah, get specific.
Exactly. We're going to pull surprising facts and actionable insights directly from the latest research, particularly some groundbreaking studies out of Brazil, to get you the exact information that matters for you and your goats. Consider this your shortcut to being well-informed, with hopefully a few aha moments along the way.
Well, and what's truly fascinating here is how goats really are global players.
Yep.
From the most arid deserts to the most humid tropics, they manage to thrive in such incredibly diverse and challenging climates.
And this isn't just luck.
No, definitely not. It's largely thanks to their built-in physiological and metabolic superpowers. Their inherent ability to cope with environmental extremes, often far better than other ruminants like cattle or sheep, is precisely what makes them such a cornerstone for so many communities worldwide. They are, in essence, biological survivalists.
Absolutely. And when you look closely, their ability to handle these tough conditions is truly remarkable. We're talking about sophisticated adaptations happening at almost every level, from, tiny molecular changes within their cells to broader metabolic shifts, complex physiological responses, and even smart behavioral adjustments.
All working together.
Yeah, and they're incredibly efficient at utilizing nutrients, squeezing every bit of goodness out of their feed, which is a huge advantage, especially when forage might be limited or of lower quality, which, let's face it, is often the case in challenging environments.
Indeed. It's important to understand that goats exhibit superior heat tolerance compared to many other livestock, including sheep and cattle. This isn't just an observation, it's rooted in their unique physiological mechanisms that allow them to dissipate excess body heat more efficiently.
How do they do that exactly?
Well, they achieve this, for example, through an increased sweating capacity. They can actually sweat more effectively than some other animals and by significantly higher respiration rates when it gets hot.
Okay.
Think of it like their built-in air conditioning system working overtime. They can breathe faster, pant more effectively, and sweat more efficiently to cool their core body temperature down. This active cooling is a major reason they survive and even produce in environments where other animals might really struggle.
And it goes even deeper than that, which is just mind-blowing when you think about it. For instance, they can efficiently digest even low-protein feeds. This is super important if you're in an area where high-quality forage isn't always abundant, or if you're trying to make the most of what's available like we sometimes have to here.
The key advantage.
They also have this amazing, almost magical ability to recycle more urea, a waste product of protein metabolism, back to their rumen.
Yeah, the nitrogen recycling.
Right. This recycling process helps them make the absolute most of the limited nitrogen they consume, essentially getting a second chance at using protein precursors. Plus, they use water incredibly efficiently and even have notably large salivary glands, which help them buffer their rumen pH and stay hydrated. All of these small but mighty adaptations contribute to their overall survival and productivity in challenging conditions.
This inherent, almost miraculous adaptability is precisely why they are so crucial, especially for resource-constrained communities globally. They are the backbone of many small farms. But here's the crucial insight. Just because they're adaptable doesn't mean they don't have specific needs. Understanding these nuanced nutritional requirements in hot climates is the key to truly unlocking their full potential and ensuring not just their survival, but their optimal productivity and well-being. It's about working with their natural strengths, not, just assuming they'll be fine no matter what.
So, because their amazing adaptability to warm conditions is so closely linked to their nutritional requirements, essentially, what they eat directly fuels their ability to cope with. Researchers have dedicated significant efforts to updating feeding systems. This isn't just about throwing more food at them, right?
No, not at all. It's about precision.
It's about getting incredibly precise, especially focusing on the energy, protein, and mineral needs of growing and pregnant goats in these hot, sometimes punishing environments. It's about fine-tuning the diet to the demands of the climate.
And to optimize profit and ensure the health and productivity of the animals. The ultimate goal of nutrition is to perfectly synchronize the feed supply with the precise nutritional requirements for specific production functions. This isn't guesswork or trial and error. It absolutely demands accurate, scientifically derived information.
Right.
Think of it like building a custom diet plan for an elite athlete. You wouldn't just guess what they need, you'd use precise data.
And when we talk about accuracy, we're talking about the established science behind the feed bag. There are several prominent feeding systems that compile this kind of data, like AFRC from 1998, NRC from 1981 and 2007, and INRA from 2018.
The big ones.
These are like the comprehensive playbooks, the Bibles, for many of us trying to get our feed right. They represent decades of aggregated research.
And most of these systems adopt what's called the factorial method. It's quite intuitive, actually. Imagine you're building with Legos. You first need a base that's the energy and protein needed just to keep the goat alive, breathing, and maintaining its body temperature, what we call maintenance. Then, if it's growing, you add more Legos for muscle and bone. That's growth.
Gotcha.
If it's pregnant, you need even more for the developing kid inside pregnancy. Each physiological function, like lactation or fiber growth, is a separate block of nutritional requirements that you add on. You total these blocks, and that gives you the goat's overall daily nutritional need. Makes sense.
Yeah, totally. Breaking it down by function. Now, a significant portion of this recent crucial research we're discussing today comes from Brazil, specifically São Paulo. And when I read about São Paulo's climate, it instantly resonated with my experience here in Florida.
Oh, I bet.
That same blend of intense heat and pervasive humidity, that feeling of the air just hanging heavy with moisture, makes this research so directly applicable to our own backyards and barns for anyone raising goats in similar conditions. It's not just academic, it's, directly relevant to daily farm life.
That's a perfect comparison. São Paulo is characterized as a tropical climate with a distinct wet summer and a dry winter, a climate classification known as AW.
Okay. Oh.
To give you some context, the average monthly maximum temperature there ranges from about 79.5 degrees Fahrenheit in June, which is their winter, all the way up to a scorching 87.8 degrees Fahrenheit in October. Minimum temperatures vary from a cooler 54.8 degrees Fahrenheit in July to a warmer 67.8 degrees Fahrenheit in January.
Wow. Yeah, that sounds familiar. And the humidity. That's the real kicker for us in Florida, right?
Absolutely.
São Paulo's highest average relative air humidity hits nearly 80% in January, their summer, while the lowest is still a significant 57.8% in August.
Yeah.
Their rainy season from October to March sees about 8 inches of rain per month, compared to a much drier season from April to September with only about 1.5 inches.
Right.
This description of their climate really sounds exactly like my summer in Florida, where the air just hangs heavy with moisture day after sweltering day. It makes you realize how much these goats are constantly working to just stay comfortable.
Precisely. And it's important to note that while much of the data comes from São Paulo, some of the referenced studies were conducted in locations with even hotter or more challenging environmental conditions, pushing the boundaries of our understanding even further.
Wow.
These are real-world studies, not just laboratory simulations, which adds a layer of practical relevance.
Definitely. So let's start with energy requirements. Just like us, goats need fuel to function, to breathe, to move, and to produce milk or meat. And how much they need is profoundly affected by their environment, especially heat.
Right. So when we talk about energy for maintenance, think of it as the goat's baseline fuel cost. It's the energy needed just to sustain vital processes without any change in body weight or composition.
Just keeping the lights on, basically.
Exactly. This includes fundamental activities like regulating their internal body temperature, supporting basic metabolic processes within their cells, and even the minimal energy expended during gentle physical activity, like standing or lying down. It's the bare minimum to keep the engine running.
And it's not just about their size or age, is it? You mentioned environment.
Correct. Environmental factors like the ambient temperature, the humidity in the air, the intensity of solar radiation, and even wind speed play a crucial, often underestimated role in determining these maintenance energy needs. It's a complex equation, far more dynamic than a simple fixed number.
Okay, so how did the older guidelines handle this?
Historically, different feeding systems have proposed varying figures for this baseline energy need. For instance, the NRC, back in 1981, suggested a net energy for maintenance, or NEM, of about 57.2 kilocalories per unit of metabolic body weight. The AFRC in 1998 recommended a slightly higher 75.3 kilocalories.
Okay.
When you convert that to metabolizable energy for maintenance, or MEM, which is the energy actually absorbed and available to the goat, it was typically estimated around 101 to 105 kilocalories per unit of metabolic body weight.
The NRC in 2007, which is what I typically use, along with Langston's calculator for my Florida girls, really started to differentiate. They broke it down by breed types, meat, dairy, indigenous, Angora, and even by sex, suggesting that MEM is about 15% greater for intact males, and that dairy goats require about 18% more MEM than meat or indigenous goats.
Getting more specific.
Yeah. So seeing these new findings is really eye-opening for someone like me trying to get it right for my Florida girls. My current playbook might not be totally optimized for our specific climate.
And this is where it gets particularly interesting and crucial for hot climates. A significant meta-analysis by Sala and colleagues in 2014, looking specifically at small ruminants in warm climates, found that the metabolizable energy for maintenance was significantly higher, around 129.7 kilocalories per unit of metabolic body weight.
Wow, 129.7 compared to like 105.
Yep, exactly. This is a substantial jump, almost 25–30% higher than for goats raised in temperate climates. The key insight here is that goats in warmer environments, like your Florida herd, are expending more energy just to maintain their body functions, even without producing milk or gaining weight.
So they're working harder just to exist.
Their bodies are working harder simply to exist and stay cool.
How did the Brazilian studies figure this out? What kind of scientific detective work did they do to get such precise numbers?
Well, the Brazilian studies primarily used a very rigorous scientific approach called the California Net Energy System, combined with a technique called comparative slaughter.
Okay, comparative slaughter sounds intense.
Don't let the name scare you. It's a method where researchers precisely measure the energy content of the feed consumed, and then at the end of the study, measure the energy retained in the animal's body tissues. The difference between what went in and what was stored is essentially the heat produced by the animal, the energy used for basic metabolism and to keep warm or cool. Net energy for maintenance, for instance, is determined by seeing how much energy is needed before any is stored. It provides a very direct and accurate measure of their baseline energy needs.
So they actually measured how much energy was going in and how much was being used or stored. That sounds incredibly precise, truly getting to the root of the numbers.
Yeah.
And what did they find regarding sex and genotype in these hot environments? Did male and female goats or different breeds have different baseline energy needs?
They did find some differences. When they didn't factor in the degree of maturity of the goats, essentially, how physically grown up they were relative to their adult size,
Okay.
they observed some interesting things. Female dairy goats, for instance, showed about 15% lower net energy for maintenance and metabolizable energy for maintenance compared to males. Furthermore, dairy and indigenous goats required approximately 8.5% less energy for maintenance than meat goats. So it paints a picture of subtle but important distinctions based on breed type and sex when you just look at them at the same physical weight.
That's fascinating. And what about the efficiency with which they convert metabolizable energy to net energy for maintenance, what they call chem? Is it like their metabolic engine's fuel efficiency?
That's a great analogy. Chem represents how efficiently the absorbed energy from their feed is actually used for maintenance. The Brazilian studies found a narrower range for chem between 0.62 and 0.64.
Okay, 0.62 to 0.64.
Yeah, this is a tighter, more consistent range compared to the broader range of 0.56 to 0.75 found in general feeding systems. Now, this narrower range might be due to the similar diets used in the Brazilian studies, which highlights a need for more diverse diet studies in the future to confirm these efficiencies across a wider array of feedstuffs and for different types of forage.
Right, need more data points. Now let's talk about pregnant goats. This is huge for us. What happens to their energy needs for maintenance in these hot conditions, especially since they're already undergoing such massive physiological changes?
Well, for mature pregnant females, the net energy for maintenance and metabolizable energy for maintenance values were found to be lower, around 47 and 75.3 kilocalories per unit of empty body weight, respectively.
Lower. That seems surprising.
It is a bit counterintuitive, but this is a crucial finding that contrasts with many general feeding systems, which often suggest higher values, around 105 to 120 kilocalories. This observed lower requirement in mature pregnant females actually aligns with a general reduction in basal metabolic rate that can occur with age, similar to an 8% annual decrease seen in sheep.
Wow.
It's almost as if their bodies become more energy efficient as they mature and manage the demands of pregnancy.
So as goats get older, their maintenance energy needs can actually decrease, even when pregnant.
Yeah.
Yeah, counterintuitive for some of us who think pregnancy always ramps up all requirements. It feels like they're just getting more efficient at being pregnant older, if that makes sense.
It does make sense physiologically, and it speaks to their incredible physiological adaptations. The discrepancies with broader feeding systems could also be attributed to the limited number of studies specifically on mature pregnant goats and how their physiological state truly affects heat production.
Right.
What's particularly important for hot climates is that these Brazilian studies were conducted in a challenging, hot environment, which could very well influence goat metabolism during pregnancy, especially in the third trimester when dry matter intake naturally decreases due to the physical space constraints of the growing fetuses.
That makes perfect sense. My pregnant food does definitely slow down on their feed intake towards the end of their gestation. It's like they hit that third trimester wall, just like a human expecting mother.
Exactly.
So it really highlights the scarcity of studies on pregnant goats under various environmental conditions and the urgent need for more research here.
Absolutely. And the animal's capacity to regulate its thermal and energy balance is directly challenged by varying ambient temperatures. Acclimatization, or, getting used to the heat, involves both behavioral and physiological adjustments.
Like what?
This can include subtle changes in their basal metabolic rate, increased respiratory rate, adjustments in nutrient intake, and even how much water they drink, all aimed at managing heat production and dissipation to stay within a comfortable range.
I know the NRC, a common guideline, recommends adjusting net energy for maintenance based on temperature differences from a midpoint thermoneutral zone of 68 degrees Fahrenheit, adding a small amount of kilocalories for each degree difference. But is that really adequate for us in tropical regions where it's almost always above 68 degrees? I mean, my goats live in a world that's consistently warmer than that benchmark.
That's an excellent critical question, and you're right to question it. The NRC recommendation was originally derived from studies considering only ambient temperatures below 68 degrees Fahrenheit in cooler climate. So applying it directly to tropical regions where temperatures are consistently above that benchmark may not be adequate at all. A Brazilian study by Lima and colleagues in 2020 found that adjustment should actually vary depending on whether the temperature is below or above 68 degrees Fahrenheit. A single adjustment factor simply isn't sufficient when the temperature range is so different.
Okay, here's where it gets really interesting for us in hot climates, and this is a potential game changer for how we think about feeding our goats. Tell me about this Kim again.
Right. The key insight from that study was that the efficiency of energy conversion for maintenance, the chem, that fuel efficiency we talked about, actually decreased in heat-stressed environments.
Decreased efficiency, so they're less fuel efficient.
Exactly. And that led directly to an increase in the metabolizable energy required for maintenance, or MEM. This means our goats are less efficient at using energy for basic maintenance in the heat. Their bodies are essentially burning more fuel just to stay cool, just to stand still, meaning they require more metabolizable energy than a goat in a cooler climate.
Wow. More energy just to maintain. That's huge.
It is huge. And this raises an important question for all goat owners. If our goats are already operating in a fundamentally different thermal environment, constantly expending more energy to manage heat, how can we apply a one-size-fits-all standard from cooler regions?
Right. We can't.
It highlights the need to question the appropriateness of a fixed 68-degree Fahrenheit thermoneutral zone for goats in hot climates. Secondly, there's a clear need for energy requirement adjustments that specifically account for environmental stressors that influence how dietary energy is partitioned and how efficiently it's used by the animal. Their bodies are just working harder.
So we need future studies that investigate thermoneutral zone standards specifically for goats in tropical regions. It's not just about temperature, but also considering different genotypes, the color of their hair or skin, and how those factors impact their energy efficiencies under heat stress.
Exactly.
It's not just about one number for every goat, it's a personalized equation based on their environment and genetics.
Precisely. This also extends to energy for growth, which is essentially the energy retained as new protein and fat in the body, building muscle and adding weight. Naturally, this changes as body weight changes due to the different patterns of protein and fat deposition as an animal matures.
Like young goats building muscle, older ones may be more fat.
Exactly. A young, rapidly growing goat is depositing more lean muscle, while an older, finishing goat might be putting on more fat.
Historically, the NRC in 1981 proposed a constant net energy for growth, or NEG, of about 4.09 kilocalories per gram of gain, while AFRC in 1998 suggested 2.3 kilocalories per gram of gain. But what did the Brazilian research reveal about sex differences in growth? Do male and female goats grow differently in the heat?
Well, Souza and colleagues in Brazil found that female dairy goats actually had greater net energy for growth than males at a given body weight, with castrated males having greater neg than intact males.
Okay, females greater neg. Why?
This difference was specifically linked to a higher body fat composition. In females, they naturally put on more fat relative to their lean mass compared to castrated and intact males. However, and this is a crucial nuance, when the degree of maturity was considered in the models, essentially, how much of their mature body size they had already reached.
That maturity factor again.
Right. These sex-related differences in neg canceled out.
Wow. So essentially, when you account for how mature the animal is, sex might not be as big a factor for net energy for growth as we thought, at least in hot environments. That's a significant finding.
It really is.
So the total net energy, which is maintenance plus growth for females and males, is similar at early growth stages, but becomes more pronounced as goats mature. It's like they're on similar tracks initially, but then their paths diverge as they get older.
Exactly. When it comes to genotype differences, Almeida and colleagues in Brazil found that indigenous and meat goats had net energy for growth approximately 25% greater than dairy goats in tropical regions.
Okay, indigenous and meat goats higher neg than dairy.
Yes, but again, similar to sex differences, when body protein was used to account for maturity, these differences largely canceled out. However, body protein itself can be highly variable, suggesting that more investigation into body composition is needed to truly refine these descriptions. The consistent message is that maturity is a powerful driver of nutrient needs.
That's a clear pattern, isn't it? Maturity often outweighs other factors. How about the efficiency of metabolizable energy for growth, or KEG? How efficiently do they convert feed energy into new body tissue?
Studies in hot environments reported Ka values ranging from 0.26 to 0.32 for dairy goats, depending on whether they were intact males, castrated males, or females, and about 0.30 for indigenous and meat goats.
So a bit of variability there.
Yes, and the Ka value depends heavily on the proportion of fat and protein in the gain. Putting on more lean protein generally results in a lower Ka because protein deposition is more energy intensive than fat deposition.
Ah, makes sense.
For instance, Saanen goats in hot environments showed a lower efficiency for protein gain, around 0.21, compared to a much higher efficiency for fat gain, around 0.81.
So what does all this mean for the actual metabolizable energy for growth, or MEG, that goats need in hot versus temperate climates? Are we talking about needing more calories for growth too?
Yes, precisely. The metabolizable energy for growth for goats in hot environments ranged quite a bit, from 7.5 to 12.8 kilocalories per gram of gain for females, 6.8 to 10.4 for castrated males, and 7.5 to 10.0 for intact males.
Okay, that's quite a range. How does that compare to the older guidelines?
In stark contrast, NRC in 2007 estimated lower MEG values, around 5.52 kilocalories per gram of gain for dairy and indigenous goats, and 4.73 for meat goats. Sala and colleagues, in their 2014 meta-analysis, indicated 5.81 kilocalories per gram of gain for small ruminants in warm climates.
So significantly lower in the older guidelines.
Yes. So overall, the total metabolizable energy needed for both growth and maintenance for goats in hot environments was generally greater than those in temperate climates. This means they actually need more calories than traditional guidelines might suggest, both to simply stay alive and to grow.
So if I'm understanding this correctly, their bodies are simply working harder in the heat, demanding more energy for everything they do, whether it's just maintaining themselves or putting on weight.
Exactly.
This implies that relying on general guidelines, especially those based on cooler climates, might mean we're consistently underfeeding our goats in hot, humid environments, or at least not optimizing their potential.
Precisely. Their bodies are constantly working harder to maintain equilibrium in the heat, demanding more energy for every function. Now let's shift to the very building blocks themselves. Protein requirements. Just as critical as energy, protein fuels muscle growth, milk production, and countless vital body functions.
Okay, protein. Protein for maintenance. What defines that baseline need for protein?
Protein requirements for maintenance include what we call endogenous urinary protein, metabolic fecal protein, and dermal protein losses. Essentially, it's the protein lost from the body through normal metabolic processes like shedding skin cells or hair, or the protein components in digestive fluids that need to be replaced.
Kind of like normal wear and tear.
Exactly. It's the constant, unavoidable protein turnover within the body.
And what did the Brazilian studies, using that comparative slaughter technique we discussed, find about protein maintenance needs in hot environments? Were they influenced by sex or genotype like energy was?
Interestingly, for growing goats raised in Brazil's hot environment, the net protein for maintenance, or NTM, the actual protein used for baseline needs, was not influenced by sex or genotype.
Oh, okay, different from energy then.
Right. For dairy goats, this baseline protein need was reported as about 1.23 grams per unit of metabolic body weight, and their metabolizable protein for maintenance, or MPM, that's the protein they actually absorb and use, was 3.8 grams per unit of metabolic body weight.
Okay, 3.8 grams MPM for dairy.
Yes. And for meat and indigenous goats, NPM was higher at 2.12 grams, but NPM remained similar at 3.8 grams. Sala and colleagues also reported an NPM of 3.51 grams for small ruminants in warm climates, which was consistently higher than for goats in temperate climates.
So for maintenance, protein needs seem to be higher in hot environments too, mirroring energy needs, but without the sex or genotype distinction that energy had. That's a significant difference from how the traditional feeding systems like AFRC or NRC present it, right?
It is.
It implies a universal bump up in protein needs for all goats in hot climates.
Yes, it is a significant difference. AFRC proposed an MPM of around 2.19 grams, and NRC 2007 suggested 3.07 grams, irrespective of sex and genotype. This indicates a general underestimation in traditional systems for goats in hot climates.
Right.
The consistent finding across these studies is that goats in heat-stressed environments simply need more protein just to maintain their basic body functions. Now, for pregnant goats, Harder and colleagues found a protein conversion efficiency of 0.40 and an MPM of 2.95 grams, which is quite close to the NRC 2007 value for mature does.
Okay, so pregnancy maintenance is closer to the standard.
It seems so, for protein at least.
So the key takeaway here for us in hot climates seems to be that, in contrast to energy requirements, protein requirements for maintenance of mature goats appear to be less influenced by climate and age. Though I imagine there's still some variability due to how scientists measure this. It's almost like their mature bodies have a more stable protein baseline regardless of heat, unlike energy.
Correct. Much of the variability in protein requirements can be attributed to the specific methods used for estimation. The comparative slaughter technique has generally yielded more reliable net protein for maintenance estimates, but methods for assessing metabolizable proteins still require further refinement. It's a complex area, and the science is always advancing.
Right. Let's move on to protein for growth. How do those needs change as a goat puts on weight?
Net protein for growth, or NPG, represents the protein retained in the body of a growing animal, building muscle and other tissues. It naturally varies with tissue deposition priority across the growth curve. Historically, NRC 1981 suggested around 195 grams per kilogram of body weight gain, while AFRC 1998 recommended a range from 126 to 154 grams. NRC 2007 later proposed an even wider range of 281 to 404 grams of metabolizable protein for growth. Quite a spread there.
Yeah, huge range. And what did the recent Brazilian research tell us about sex differences in NPG? Do male and female goats put on protein differently?
Souza and colleagues, in their meta-analysis of dairy goats in hot environments, found that female goats actually had lower net protein for growth than males at a given body weight.
Low NPG for females.
Yes. However, similar to energy, when net protein for growth was estimated based on the degree of maturity again, how fully grown they were in relation to their mature size.
Here we go again with maturity.
Yes. Sex no longer affected the NPG, resulting in a general NPG of about 176 grams per kilogram of body weight gain. This really reinforces that degree of maturity is the overriding factor for protein growth needs too.
That degree of maturity factor is truly powerful. What about genotype differences for protein growth? Do different breeds have different protein needs for growth in the heat?
Almeida and colleagues found that net protein for growth was similar among dairy, meat, and indigenous growing goats in hot environments, ranging from 166 to 173 grams per kilogram of body weight gain.
Stellar, okay.
So, under these specific hot conditions, genotypes seem to have less impact on overall protein accretion than maturity. The efficiency of metabolizable protein for growth, or KPG, in these studies was reported as 0.52 for dairy goats and 0.55 for indigenous and meat goats.
And efficiency matters.
It does, although while a single value is often used, it's important to acknowledge that a constant efficiency may not fully represent the animal's real efficiency, as it varies with how much lean muscle versus fat they are putting on.
Right, it's dynamic. Now, this next bit is really intriguing, and it's a testament to how incredible ruminants are, urea nitrogen recycling. I know it's important for them, but how does it specifically fit into the protein needs of goats in hot climates?
Yes. Urea nitrogen recycling plays a vital, almost overlooked role by contributing to the available nitrogen in the gut, which the rumen microbes can then use to build microbial protein.
So they reuse their own nitrogen waste.
Essentially, yes. This process is affected by several factors, including the goat's physiological stage, the diet composition, overall protein levels, and crucially, water deprivation, which is unfortunately all too common in hot environments.
Droughts, heat waves.
Exactly. Goats actually have a high dependence on nitrogen intake for nitrogen retention, even more so than sheep and cattle, making this recycling especially critical for them.
And here's the surprising part I read about. In situations of water deprivation, that urea nitrogen recycling in goats actually increases significantly, from about 79% to a remarkable 95%.
That's right. It's a huge jump.
This means they become incredibly efficient at holding onto and reusing nitrogen, leading to an improvement in their overall nitrogen balance. That's a huge adaptation, almost like a built-in protein-saving mechanism.
It is indeed. The implication here is that goats reared in hot environments may have different protein requirements than those recommended for goats in temperate climates, partly due to these specific enhanced adaptations. They are able to wring more out of less.
So they might need less dietary protein than we think under certain conditions.
Potentially, or rather, their ability to cope with lower protein intakes might be better than assumed due to this enhanced recycling. Further studies, especially comparing growth and mature weights of different genotypes and evaluating urea nitrogen recycling under various conditions, are essential to refine the accuracy of protein requirements and potentially optimize feed strategies to leverage this natural ability.
Fascinating. Okay, moving on to mineral requirements. These are often the hidden needs, right? The microscopic elements that are easily overlooked but are absolutely critical for health and production. What's the latest on their maintenance needs in hot environments?
Right. Mineral requirements for maintenance represent the absorbed mineral necessary to replace endogenous losses through feces, urine, and even through their skin and hair. While there's limited information on how the environment directly impacts these mineral losses, Brazilian studies do suggest potential differences, especially when compared to temperate climate recommendations.
Did sex play a role in mineral maintenance requirements like it did for some energy needs?
Well, Vargas and colleagues found that sex generally did not affect net requirements for maintenance of calcium, phosphorus, and potassium in growing dairy goats in hot environments.
Okay, no difference for KPK.
However, magnesium requirements for maintenance, or NMGM, were greater in intact males at 2.6 milligrams per kilogram of body weight compared to castrated males and females at 1.4 milligrams.
Magnesium for intact males. Wow.
This aligns with magnesium's crucial role in nutrient metabolism and cellular energy production. Intact males, generally more active and with higher metabolic rates, might simply need more of this vital mineral. Interestingly, these NMGM values in hot environments are lower than what traditional guidelines like NRC 2007 and INRA 2018 recommend.
Lower again. Interesting. What about calcium and phosphorus, specifically for maintenance? These are the big ones for bone health and overall function.
For calcium, growing dairy goats in hot environments needed about 21.1 milligrams per kilogram of body weight, which is similar to the NRC recommendation.
Okay, calcium, similar to NRC for growing.
However, mature pregnant goats in hot environments showed a much higher net calcium for maintenance of 60.4 milligrams, highlighting how intensely their physiological state supporting a pregnancy changes these needs.
Big jump for pregnant does.
Yes, and the calcium absorption coefficient in hot environment studies was also higher at 0.66 compared to AFRC's zero point 0.55 and NRC's zero point 0.45, potentially due to species-specific differences in how efficiently goats absorb calcium.
So they might absorb it better, too.
Possibly. For phosphorus, growing goats required about 22.8 milligrams per kilogram of body weight, which is lower than sheep values, while pregnant goats needed 31.1 milligrams. The phosphorus absorption coefficient was 0.69, generally within the standard feeding system range.
Okay, now here's where it gets really interesting for us in hot climates.
Oh.
My mind immediately goes to the salt licks and mineral mixes I put out for my goats. Why are the numbers for sodium and potassium so incredibly different from what the standard feeding systems recommend? Are my Florida goats secretly mineral misers?
That's a good way to put it. And this is truly a standout finding and one of the most surprising facts from this research. The discrepancies for sodium and potassium in hot environments compared to temperate feeding systems are huge.
Huge how? Give me the numbers.
For growing Boer goats, sodium requirements for maintenance, or NNAM, were found to be just 5 milligrams per kilogram of body weight.
5. Just 5 milligrams. Compared to what?
Compared to MESH's recommendation of 15, or AFRC and NRC's 8, or INRA's 11, it's much lower. Similarly, mature pregnant goats needed only 10.4 milligrams of sodium, still lower than the 15 milligrams recommended by AFRC and NRC.
That's insane. What about potassium? I know that's also a key electrolyte.
Even more dramatic. For potassium, growing dairy goats needed a mere 4.0000 milligrams per kilogram of body weight.
4. Compared to what?
Compared to INRA's 105 or NRC's 38. Pregnant goats also showed significantly lower potassium requirements at 15.4 milligrams.
Wow. Okay, this isn't just a small adjustment. This is a completely different scale.
It absolutely is. This isn't just a numerical shift, it's a profound display of their heat adaptation. Goats in tropical climates appear to have evolved incredibly efficient internal mechanisms to conserve these vital electrolytes, unlike how standard recommendations, often based on sheep or cattle, might lead us to oversupplement.
So the takeaway is less is more.
For these specific minerals, sodium and potassium, in hot conditions, the key insight here is that less can truly be more, potentially changing how we formulate our mineral mixes entirely.
Those are staggering differences.
Yeah.
So what explains this? Why would goats in hot environments need so much less sodium and potassium than the traditional guidelines suggest? It's like their bodies are performing a biological magic trick.
It is truly remarkable. These significant discrepancies may indicate profound physiological adaptations of goats to hot environments. Sodium and potassium are directly involved in crucial processes like maintaining osmotic pressure, regulating acid-base balance, and controlling water retention.
Right, electrolytes.
Exactly. This points to their pivotal role in metabolic adaptations to heat, including how they manage electrolyte loss through sweating, how their increased respiratory rate impacts mineral balance, how they consume water, and even subtle renal adjustments in their kidneys to conserve these vital minerals. Their bodies are actively working to hold on to these minerals, meaning their dietary need is lower.
It's like their bodies are so finely tuned to hot conditions that they manage these minerals differently. So we can't just blindly follow guidelines based on cattle or sheep data, can we? We might actually be giving them too much of what they don't need, potentially creating imbalances.
Indeed. It's a common challenge. Feeding systems often base mineral recommendations on cattle and sheep data, which can be imprecise for goats due to fundamental species differences in mineral metabolism and their unique adaptations.
Yeah.
Also, discrepancies arise from different estimation methods. Brazilian studies primarily used comparative slaughter, which is very direct, while others used radioisotope tracers or methods based on minimum endogenous losses, each with its own specificities and potential for variation.
And nutrient interactions. Do they complicate things further, like certain minerals affecting the absorption of others?
Yes. The interaction between various nutrients is a complex area. Sex, for instance, plays a role in the associations among body protein, fat, and major minerals in growing goats. It's a field that needs further attention because these intricate interactions can significantly affect nutrient body deposition and utilization.
Okay.
Overall, mineral requirements for maintenance are influenced by sex, specifically magnesium, physiological state, like calcium for pregnancy, and environmental conditions. These differences between hot and temperate regions highlight the critical need for more research on the environment's precise impact. It's like a complex web, and we're only just starting to map out all the connections, especially when heat adds another layer of challenge.
Totally. Now let's talk about minerals needed for growth. Younger goats naturally have higher needs for minerals since so much of their rapid body gain is skeletal tissue, building bone. What did the research tell us about them?
That's right. And for growing goats, Mendonça and colleagues, looking at early growth stages from about 10 to 33 pounds, found that sex did not affect the requirements for calcium, phosphorus, magnesium, sodium, or potassium.
Okay. No sex difference in early growth minerals.
Right. This implies that for young, rapidly growing animals, the mineral needs are fairly universal regardless of whether they are male or female. However, a broader database studied by Vargas and colleagues found that major mineral requirements for growth are generally not affected by sex, except for magnesium, which remained greater in males regardless of their degree of maturity. This aligns with what was observed for maintenance requirements.
Magnesium again for males. Consistent. What about indigenous and local breeds in hot environments? Are their mineral requirements different for growth? I would imagine their bodies are inherently tuned to those conditions.
You're exactly right. These breeds are inherently adaptable, having evolved over generations in challenging environments. Studies show differences in their calcium, phosphorus, magnesium, sodium, and potassium requirements compared to feeding systems derived from temperate climates.
Differences how? Higher. Lower.
Often lower, particularly for sodium and potassium, suggesting enhanced conservation. This suggests that the physiological adjustments these goats make to cope with challenging environments have a notable impact on how minerals are accreted in their bodies, likely making them more efficient.
And for meat goats?
For meat goats raised in hot environments, requirements for minerals for growth generally decrease as the animals grow. Again, sodium and potassium showed the greatest discrepancies compared to feeding systems.
A and K again.
Yes. This consistently reinforces the idea that their involvement in thermoregulatory processes like changes in respiratory rate, blood flow, heart rate, sweating, and altered metabolism means that losses through perspiration and sweating are a direct environmental impact on their mineral needs, and their bodies are actively compensating for this, leading to lower dietary requirements than might be expected.
So that connection to thermoregulation keeps coming back, particularly for sodium and potassium. It seems like a consistent theme. Are there any research gaps when it comes to mineral requirements for growth that you'd like to see addressed?
Well, while breeds certainly may influence mineral requirements, there's surprisingly no study specifically investigating the effect of breed on mineral requirements for goat growth in hot environments. That seems like a big gap.
Yeah, you'd think breed would matter.
Exactly. More studies are clearly needed for production systems in hot conditions to not only optimize production and ensure the goats are getting exactly what they need, but also to reduce mineral excretion into the environment. Knowing precise needs helps in all aspects of sustainable farming.
Definitely. All right, let's talk about the next generation. Pregnancy requirements are crucial, supporting not just the mom, but the incredibly rapid development of the fetuses inside. What did the research find here? This is so critical for the future of any herd.
Information on the nutritional requirements of pregnant goats is surprisingly scarce, especially comprehensive studies. The Brazilian studies by Herder and colleagues are truly key here, filling a significant void.
How they'd study it.
Their methodology involved fitting an exponential model to the total energy and nutrient content of the gravid uterus and mammary gland throughout pregnancy. This allowed them to track precisely how much energy and nutrients were being deposited into the pregnancy products over time.
So they essentially track the energy and protein going into the pregnancy products over time. What did they discover about the net energy for pregnancy, or NEP, and net protein for pregnancy, or NPP? Was it a steady increase or something more dynamic?
They found that the net energy for pregnancy and net protein for pregnancy were determined by deposition. But here's the crucial, fascinating finding. The efficiency of metabolizable energy utilization for pregnancy, KP, And metabolizable protein utilization for pregnancy, KPP, actually increased as pregnancy
The
progressed.
increased efficiency. That's really interesting. So the mother's body becomes more efficient at channeling energy and protein to her developing kids as the pregnancy goes on. Can you give us those numbers again? That's so compelling.
Exactly. For KP, it went from a relatively low 0.058 at 80 days of pregnancy, which is roughly mid-gestation, all the way up to 0.19 at 140 days, just before kidding.
Wow, more than tripled.
Yes. And for KPP, it climbed from 0.12 at 80 days to a much higher 0.43 at 140 days.
Huge increase there, too.
hmm If we connect this to the bigger picture, this progression makes immense physiological sense. The fetus has incredibly rapid growth in the later stages, demanding a substantial increase in nutrient transfer from the mother. The mother's body, like a finely tuned factory, becomes remarkably efficient at channeling those critical nutrients directly to the growing fetuses, almost optimizing its internal supply chain to meet that surge in demand. It's a biological marvel.
That makes perfect sense for the rapid growth phase of the fetuses. How do these findings compare to what the standard feeding systems like AFRC and NRC suggest? Are we underestimating their needs in late pregnancy?
Well, Herder and colleagues found that both AFRC 1998 and NRC 2007 generally underestimate net energy for pregnancy and net protein for pregnancy towards the very end of pregnancy.
Underestimate the net need.
Yes,
Yeah.
and their proposed KP of 0.133 is lower than what the Brazilian studies found, meaning they might assume less efficient energy transfer. And their KPP values at 0.85 and 0.70 respectively are much higher than those observed in the Brazilian research.
Wait, higher KPP? That means they assume more efficient protein transfer.
Exactly, which seems contradictory to the Brazilian findings. This suggests that the actual efficiency of protein transfer might be lower than previously assumed in those systems, implying a greater need for dietary protein in the late stages to meet the net protein requirement.
Why such a big discrepancy? Is it a difference in how the research was done?
Part of it comes down to methodological differences. Traditional feeding systems often extrapolate from pregnant sheep data or base their figures on the body composition of kids at birth, rather than assessing the composition of pregnancy products throughout the entire gestation in goats.
Ah, so not tracking the whole process.
Right. This can lead to a less accurate or complete picture for goats, especially regarding the dynamic changes in efficiency over time.
What about the physiological changes in the pregnant goat's body during this time, especially in a hot environment? How do they cope with this double stress of pregnancy and heat?
It's well known that pregnant females experience reduced feed intake capacity in the latter half of pregnancy, typically from around 76 days onwards, due to hormonal effects and the physical pressure of the expanding uterus on the rumen.
Yeah, they just run out of room.
Exactly. This can be a challenge in itself. Paradoxically, during this very period, the products of pregnancy experience an accelerated rate of protein and energy growth. This explains the observed increase in KP and KPP as pregnancy progresses. The maternal body is prioritizing fetal development above almost all else.
So the mother's body is making huge adjustments to ensure the fetus gets what it needs, even if her own intake is reduced. It's like she's tapping into her own reserves to fuel the next generation.
Exactly. Pregnant goats make significant physiological adjustments, including the mobilization of their own body fat and protein reserves, to meet the intense demands for fetal growth.
How do we know that?
Well, they can actually reduce their own body protein and fat accretion, accompanied by increases in non-esterified fatty acids and ahydroxybutyrate, which are indicators of fat mobilization, and an increase in that crucial urea recycling we discussed earlier.
Wow.
Despite these significant maternal adaptations, the physiological changes during pregnancy did not impact the overall requirements of protein and energy for pregnancy or for maintenance. This suggests the maternal body will adapt to challenging environments to support the fetus as a priority.
That's a testament to their resilience. How did the breed of goat factor into their ability to handle heat stress during pregnancy?
Well, Bilato and colleagues in 2022 reported that pregnant Kakang goats in Indonesia were not adversely affected by medium heat stress. They attributed this to the high adaptability of that specific breed to challenging environmental conditions, similar to how certain cattle breeds are known for their inherent heat tolerance.
So breed matters for heat tolerance in pregnancy.
It certainly seems to. The Brazilian goats in the studies we've discussed were also exposed to environments where temperatures exceeded their typical comfort tolerance range and humidity levels sometimes fell below their comfortable range. So, these findings are highly significant for understanding how goats truly respond to such challenging conditions. Nevertheless, more studies in extremely hot environments are still needed to determine the absolute limits of what pregnant goats can support.
Right. There's always a limit.
Hmm.
So their bodies are truly amazing at adapting, even under the immense pressure of pregnancy and heat. Let's look at minerals for pregnancy now, as they're foundational for healthy bone and tissue development in the developing kids.
Right. Net mineral requirements for pregnancy refer to the actual mineral accretion in the pregnancy products, including the gravid uterus, the fetuses themselves, the amniotic fluids, the placenta, and the development of the mammary gland during pregnancy. These are the minerals physically incorporated into the growing offspring and supporting tissues.
And what did Herder and colleagues find about how mineral accretion changes during pregnancy compared to what the feeding systems tell us? Did it follow that increasing efficiency pattern too?
Well, they clearly demonstrated that net mineral accretion rates increase as pregnancy progresses. This means the demand for minerals isn't static, it ramps up significantly towards the end of gestation.
Okay, increasing demand over time.
Yes. This is a significant difference from the recommendations of many feeding systems, which are primarily based on fetal composition at birth and tend to assume a more constant mineral accretion rate during pregnancy, with only a notable increase in the last third. This implies that many traditional guidelines might be underestimating mineral needs throughout much of the gestation period.
So again, the feeding systems might be underestimating mineral needs throughout the gestation period, particularly for those crucial middle months.
And indeed, when comparing dietary mineral requirements during pregnancy, particularly for minerals like sodium, it becomes evident that feeding systems tend to overestimate the mineral requirements for most minerals.
Overestimate. Why?
This is because differences in maintenance requirements for pregnant goats also contribute significantly to the overall mineral requirements. If the maintenance need is lower, the total need might be overestimated. It's also worth noting that some systems, like AFRC, provide limited information on sodium and potassium requirements for pregnancy, which is a major gap given their importance in thermoregulation.
Given the crucial role minerals play in so many bodily functions, especially in hot environments, things like regulating body temperature, metabolism, and fluid balance, understanding how pregnant goats adapt their mineral metabolism is incredibly important. It's not just about what they need to build bone, but what they need to cope with the heat.
Absolutely. Minerals like calcium play a role in thermoregulation, phosphorus and magnesium in energy metabolism, and sodium and potassium in osmolarity and acid-base balance, all of which are stressed in hot conditions, so their proper balance is critical.
Right.
Despite the scarcity of studies on mineral requirements for pregnant goats in extremely hot regions, the Brazilian data, obtained from goats in a hot environment, do provide valuable insights for such climates, highlighting their remarkable adaptations in mineral conservation.
And what about the impact of feed restriction on minerals during pregnancy? That's a real-world scenario for many goat owners, especially in areas prone to drought or limited forage. How do the does cope?
Right. Herder and colleagues conducted a critical study on mineral metabolism in pregnant goats under feed restriction. They found that with moderate feed restriction, the maternal body showed an amazing ability. It used its own reserves to maintain gestation, preventing a decrease in fetal mineral deposition.
Wow, protecting the fetus again.
Exactly. This is a remarkable, almost protective adaptation, ensuring the fetus gets what it needs first. However, under more severe feed restriction, a stark difference emerged. Phosphorus, sodium, and potassium content in the fetuses were compromised.
Oh.
These were the primary minerals the maternal body prioritized for its own use, perhaps because they are so critical for its immediate survival. Interestingly, calcium and magnesium deposition in the fetuses remained unaffected, indicating the body's strong drive to preserve skeletal development in the offspring.
Still trying to build strong bones.
Yes, but overall, severe restriction also led to decreased retention of all minerals in the maternal body and resulted in fetuses with a lower average mass, illustrating the limits of this adaptation. These findings can guide future studies to better predict the performance of pregnant goats in hot climates and inform management strategies.
That's a powerful insight. It really helps us understand which minerals are most vulnerable under stress, and that while goats are incredibly resilient, there are limits. So, we've covered a lot of groundbreaking research, uncovering many surprising facts, but what are the limitations in current studies, and what still needs to be learned to fully optimize goat nutrition in hot climates?
Well, a primary strength of many of the reviewed studies is their use of the comparative slaughter technique, which, as we discussed, is highly accurate for estimating net requirements. However, this method is expensive, requires a high number of observations, and relies on assuming initial body composition, making it resource intensive.
Right, not practical for everyday use.
Yeah,
But researchers are also using other, more advanced methods to fill in the gaps.
right. Yes. Scientists are continuously adopting innovative techniques to improve accuracy and reduce the invasiveness of these studies. For instance, some are using stable isotopes to improve understanding of calcium dynamics within the body, or employing respirometry to investigate the precise effect of temperature on energy expenditure. These evolving methodologies are crucial for improving the accuracy and precision of specific nutritional requirements.
What about diet diversity in the studies? Many goats in hot climates, like my own, graze on a wide variety of forages, not just a controlled lab diet. Does that limit things?
That's a significant limitation in the current body of research for this review. The database had a relatively small diversity of diets used in the studies. This can potentially bias efficiency values and highlights the urgent need to expand studies to include diverse diets, such as local forages, agricultural byproducts, and low-quality feeds, which are common in real-world goat production systems, especially in hot climates where feed resources can be scarce or inconsistent.
Yeah, we need data on what they actually eat. And grazing goats. Many of us have goats out on pasture, moving around and expending energy. Was that addressed?
Unfortunately, the inclusion of studies on grazing goats in the reviewed literature is limited, which constrains the estimation of dietary requirements and their direct applicability to goats under free-range grazing conditions. Energy expenditure in grazing goats is expected to increase significantly due to their activity levels, walking, foraging, fighting for hierarchy. But these aspects couldn't be fully addressed in this review, representing a key area for future research.
Big gap there. And for dairy goats, what's a major gap in the research?
A significant limitation, especially for the global dairy goat sector, is the surprising lack of comprehensive studies involving lactating goats in hot environments.
Really? Lactating goats?
Yes, understanding their specific energy, protein, and mineral needs while they're actively producing milk in heat stress is a crucial area that deserves immediate attention in future research.
Definitely need that. And how about nutrient interactions? Were we missing something there, like how one nutrient might influence the absorption or use of another, especially under heat stress?
The interaction between nutrients was scarcely explored in the studies considered, and this is a major area for growth in the research. These interactions can significantly affect nutrient body deposition and utilization.
How so?
While this is particularly relevant for animals in hot environments, where increased energy expenditure for various functions, such as protein synthesis and degradation and heat dissipation, may lead to complex interactions. For example, adequate levels of one mineral might be crucial for another to be absorbed properly, and heat stress might disrupt that delicate balance. It's like a complex web, and we're only just starting to map out all the connections, especially when heat adds another layer of challenge.
So looking ahead, with all this new knowledge and understanding of their unique adaptations, what are the future perspectives for goat farming? How can innovation help us better manage our herds in these challenging climates?
This is where the science truly gets exciting and offers immense potential for goat owners. Precision livestock farming and precision feeding are key. Imagine using innovative technology to enhance goat management in hot environments.
Like what kind of tech?
This could involve integrating behavioral changes, health events, and environmental data directly into sophisticated models that predict each animal's specific nutritional requirements and even its feed intake in near real time. This not only reduces feed costs by preventing waste, but also dramatically enhances animal efficiency and well-being by optimizing nutrient delivery, promoting better health and productivity.
I can imagine how real-time data could make a huge difference in managing my herd. Instead of just guessing, I'd know. Are there actual technologies available or being developed for that right now?
Absolutely. Near real-time sensors and information technologies are becoming invaluable tools for measuring variables that influence nutritional efficiency, helping to refine feeding management on the farm.
Like wearables for goats.
Exactly. While many solutions were originally designed for larger ruminants like cattle, they are being rapidly adapted for goats. For instance, accelerometers, small devices worn like a collar or attached to an ear tag, can monitor physical and behavioral activities like feeding duration, rumination time, and lying patterns in goats. On-farm monitoring systems can provide real-time welfare insights by combining environmental data, like temperature and humidity, with behavioral data. These technologies can significantly improve the accuracy of nutritional requirement estimates by accounting for an individual goat's activity level and the specific environmental conditions it's experiencing.
So it's about getting more precise information on individual animals or small groups. And what about using genetics to breed goats that are naturally better suited for hot environments?
Genomic selection is another promising approach, a powerful tool for the future. By using DNA markers, we can identify and select animals with desirable traits, not just for production, but also for heat tolerance and highly efficient feed utilization.
Breeding for resilience.
Exactly. This is a long-term strategy to improve production efficiency while reducing costs and environmental impact, creating herds that are inherently better suited to the climate.
And what about getting faster, less invasive information on how my goats are actually doing internally? I know the comparative slaughter method is precise, but it's not something I can do on my farm.
That's a valid point. Using indirect methods for rapid in vivo monitoring of body composition, meaning assessing the goat's body fat and muscle content without harming the animal, would be a huge leap forward.
How would that help?
This would allow farmers to feed goats to their exact requirements at different stages of growth or pregnancy. This leads to both significant economic gains through feed cost savings and environmental benefits by reducing nutrient excretion, leading to a more sustainable and profitable operation.
Ultimately, it sounds like a holistic approach is needed, pulling all these threads together for truly optimized goat management in hot climates.
Precisely. Integrating nutrition, genetics, environmental management, reproduction, and overall health is key for improving goat management in hot environments. It's about understanding the whole system, not just isolated parts, and using the best available science and technology to support these incredibly resilient animals.
So what does this all mean for you and your goats, especially if you're like me here in the Florida heat? It means those general feeding guidelines we've relied on might not be giving our goats everything they truly need, or in some cases, might be overestimating certain things like sodium and potassium needs.
A critical point.
This research is a game changer for precision feeding. We've learned that several factors like sex, genotype, and pregnancy type do influence their dietary nutritional requirements. But importantly, sex and genotype primarily influence growth requirements only when the degree of maturity isn't considered in the models. It's their stage of life that often matters most.
Right, maturity is key.
But the most crucial takeaway for us is that the nutritional requirements of goats in hot environments differ significantly from those in temperate climates. We saw that decreased energy utilization efficiency in hot environments leads to increased metabolizable energy requirements. They simply need more fuel to cope.
Yep, more calories needed.
Plus, the metabolizable protein requirement for maintenance in hot environments is higher. And for our pregnant does, the efficiency of energy and protein utilization for pregnancy actually increases as pregnancy progresses, meaning their bodies get incredibly efficient at channeling nutrients to their growing kids.
Amazing adaptation.
These differences underscore the necessity of tailoring nutritional models specifically for goats in hot climates, considering their unique challenges and physiological adaptations. It's not one size fits all.
Absolutely not. And this raises an important question. Considering how incredibly adaptable goats are to their challenging environments and how their bodies adjust their energy, protein, and mineral usage with such precision, what other hidden nutritional superpowers might they possess that we're only just beginning to uncover?
Good question.
And how can we leverage that knowledge to truly optimize their health and productivity in any climate, making them even more sustainable and valuable for communities worldwide?
That's a fantastic thought to leave us with. So keep learning, keep observing your own animals, and remember that the science is always evolving to help us better care for our incredible goat herds. Until next time, keep those goats happy and healthy.